Welcome to Networks Professionals.
Okay, let's dive right into this. Today, we're unpacking the invisible infrastructure that's literally powering our modern digital lives. We are looking at an absolutely foundational concept in network engineering. It's something that builds just incredible resilience into a system, and it's called EtherChannel. Now, to really grasp why this technology even exists in the first place, I want you to imagine your everyday commute. Specifically, what happens when your network reaches its absolute physical limit? Just picture a massive standstill traffic jam on a single-lane road. You've got all these cars, right? And they perfectly represent our data packets, all trying desperately to get from point A to point B. But they're completely bottlenecked by a highly congested physical Ethernet link. And the thing is, no matter how fast those data packets want to move, that single physical lane strictly dictates and severely limits your overall throughput. So don't worry, here is our roadmap for this explainer. First, we'll look at the network traffic problem. Then we'll answer what is EtherChannel. After that, we'll cover its 4 major network benefits, compare LACP versus PAgP protocols, and finally finish up with empowering your network infrastructure. It's a lot of great stuff, so let's get started. All right, Section 1, the network traffic problem, looking specifically at bottlenecks and link failures. And this brings us right to Section 2. What is EtherChannel? The ultimate solution. Now, what's really interesting about this is how this technology quickly becomes the absolute hero of our networking story. You know, in modern networking, hitting those throughput limits or suddenly losing connection to critical servers, those are massive, massive pain points. Relying on just a single physical cable, well, that creates a huge single point of failure. But when we talk about overcoming this exact vulnerability with EtherChannel, the magic number to remember here is 8. This port link aggregation technology fundamentally allows you to take up to 8 active physical Ethernet links and bundle them all together into one massive high-capacity superhighway. It's a real game changer. And creating this physical bundle forms what we actually call a port channel. By definition, that's a single logical connection formed by bundling multiple physical links between your switches, routers, and servers. To ground this in exact networking engineering terminology for a second, those separate physical wires, they no longer act independently. To the networking devices on either end of the connection, this bundle functions entirely as one single cohesive entity. Moving right along to Section 3, 4 major network benefits, or as I like to call them, EtherChannel's superpowers. So the very first major benefit here is increased bandwidth. When you aggregate these cables together, it's exactly like actively adding wide new lanes to that previously congested highway we talked about. You are taking the physical capacity of multiple cables and aggregating them into a single connection. And doing that massively multiplies your total data throughput. Now, the second major benefit is high availability and redundancy. And let's face it, uptime is literally everything in networking. If one physical link in your new bundle fails, say, a cable gets accidentally unplugged or a port's hardware just goes bad, your network actually doesn't go down. The traffic is instantly, seamlessly rerouted right through the remaining active links in that bundle. This convergence happens in just fractions of a second. That means user sessions stay completely active and you don't drop the connection. Then we have the third massive benefit, which is load balancing. Going back to our superhighway analogy for a sec. Load balancing efficiently distributes those cars, our data, evenly across all available highway lanes so that no single lane ever comes to a grinding halt. Using specific hashing algorithms based on MAC or IP addresses, EtherChannel intelligently distributes your data traffic across all the physical links in the bundle. This practically guarantees that no single link gets overwhelmed, perfectly optimizing your network performance. And our fourth superpower is simplified spanning tree, or STP behavior. Think of STP as a super strict traffic cop that normally just shuts down redundant roads to prevent catastrophic switching loops. But because EtherChannel uses this clever single interface disguise, that strict traffic cop is completely pacified. STP treats the entire bundle as just one single port, which allows you to use all your bandwidth safely without dealing with any of those major loop resolution headaches. All right, Section 4, LACP versus PAgP protocols, the rules of engagement. Let's move to this and see how it builds as we introduce the automated negotiation protocols that actually govern this highway. Now, while EtherChannel can absolutely be configured manually, out in the real world, it's almost always negotiated automatically using these underlying protocols. And this brilliantly illustrates a bit of a showdown between the 2 major automated negotiation protocols. First up is LACP, or Link Aggregation Control Protocol. This one is an open IEEE standard. It relies on active and passive modes to establish links, which gives you the immense flexibility of multi-vendor bundling. On the flip side, we have PAgP, or Port Aggregation Protocol. This one uses desirable and auto modes. It's entirely Cisco proprietary, meaning it's specifically designed for automating links strictly between Cisco devices. Finally, Section 5, empowering your network infrastructure, and honestly, why all of this really matters to us. You see, mastering how to deploy this technology across your network infrastructure, it isn't just some abstract theory. It literally dictates your everyday network performance and your maximum reliability. So to put this into practice, I highly recommend consulting the comprehensive Cisco EtherChannel documentation for precise deployment details. Additionally, you should absolutely take the time to read through the Geeks for Geeks EtherChannel guide. It provides a phenomenal, really thorough breakdown that will massively benefit anyone who is currently tackling their CCNA studies or getting ready to execute a new network deployment. So, as we wrap up this explainer, I want to leave you with one final, provocative thought based on everything we've unpacked today. If just one single cable fails in your setup right now, will your network survive? Or is it finally time to build a superhighway? Take a really hard look at your current configurations and seriously consider the power of EtherChannel. Thanks so much for joining me today. Keep learning, and I'll...
Thanks for watching.